And then we're going to multiply that by the derivative of the inside function. Derivative of the inside function is 2. Now in this particular problem, that 2 and that 2 cancel out. So my derivative is just 1 over square root 2x plus 3. Piece of cake. Let's do one more. Now we're really going to kick it up a notch. The square root made it a little bit harder because we had to use that other formula. Now what makes this one harder? We've already done the sine of something. It's the fact that we actually have the sine of something and another function. So notice there's actually 3 functions embedded here. There's the sine function, the 3x plus 1 function, and then the squared function. All are kind of nested within one another. Now the first thing you have to remember here is that the order in which these functions are used. Remember that this squared means the whole thing is being squared. So if you don't remember that, it's a really good idea to rewrite these problems, if you have trig functions squared, to rewrite them a little bit more literally. Like that. Because that's really what it means. This is shorthand notation for this. Okay? Now, if we have more than one function, to differentiate it, we're going to start with the outside and work our way down to the inside. Okay, so here's the way I would think about this one. I think about the outermost function is something squared. So the derivative of something squared is 2 times that something. Lower the power by 1, which is 1. But now I have to multiply by the derivative of the inside. But notice that the inside function is itself a composition. So the derivative of the inside function, there's the inside function, is going to be derivative of sine, which is cosine, of 3x plus 1, times the derivative of the innermost function. The derivative of the 3x plus 1 is 3. So there's 2 multiplication adjustments you need to make on this function. One for the first level and one for the second level. Right? Now, just putting it all together, I'll put the 3 and the 2 together to make 6. The other stuff just can't really be simplified, so I'm just going to write them down next to each other. So that would be the derivative of that function. Okay, so it's a little tricky when you have more than one function embedded. Okay, so it's time for you guys to try a few more examples. The only way you're going to get better at these is to actually work on them and try them. Although watching it, it might look easy when you watch, you actually need to do the problems because that'll help you learn them. Okay, so I'll come back and go through the results in a second. Let's say the first function. That one. I'll try to write them down correctly this time. That's a negative 3. It's sine squared times cosine cubed. And that last one will be a little bit of a challenge. Okay, so why don't you guys take 5 to 10 minutes, try to find the answers to these 3 problems. And again, so if you could pause the tape, I'll come back in that time and go through the solution. Good luck. Okay, well, let's talk through the answers to these. The first one, there's only one function inside of another function. So it's just straight chain rule. So the derivative of this, I start with the outside function. The derivative of tangent, remember that one from last time, is secant squared. So the derivative of tangent something is secant squared of that something. But then we have to multiply by the derivative of the inside. The derivative of the inside is 2 minus 3x squared. Okay. And to finish up, I would probably write this out in front, but it's not that big of a deal. So there's not really anything else you can simplify. Because this stuff all goes together. It's secant squared of all this, answer times this, and you can't like combine these parentheses in any way. Okay. All right, second example. This time, the outermost function is the negative 3. So it's like something to the negative 3 power. So the derivative of something to the negative 3 power would be negative 3 times that something. Lower the power by 1 would make it negative 4. Times the derivative of the inside. Well, the derivative of the inside is just square root x. Derivative of the 4 is 0. So the derivative of square root x is 1 over 2 root x. Which in this case I would simplify by combining these two terms together. So it would be negative 3 over 2 root x times that expression. So this is my final answer there. Okay, now the last one's a toughie. Because not only are you going to have to use the chain rule, but there's also another rule you have to use here. Hopefully you noted this. There's actually a product. So before you use the quotient rule or the chain rule, you actually have to either use the product or the quotient rule if it's implied multiplication or division. So my first step in doing this derivative would be to use the product rule. It's the first function times the derivative of the second. Well, the derivative of cosine cubed, remember that's cosine x quantity cubed, would be, actually let me kind of do it a little more slowly. I'm just going to literally write down what I'm doing here. So first function times the derivative of the second, so I'll just literally write derivative of the second, plus the second function, cosine cubed, times the derivative of the first, which again I'll just write that derivative. Especially for those of you guys who are starting to struggle with this, it's really important to make sure you write down all the steps really clearly. And so even though you might be thinking about, well, why don't we just do the derivative instead of write that? Well, that's another step you're doing in your head, and it could lead to errors because you're thinking too many things at once. So at least for right now, try to take it slow and do one step at a time, and as you develop some proficiency, then you can start doing more of those steps in your head. Okay, so cleaning this up, the derivative of this, it's cosine quantity cubed, so the derivative of this, using the outside function first, outside function being something cubed, would be 3 times cosine x squared times the derivative of the inside function. Now here, the inside function is cosine x. Derivative of cosine is negative sine. Okay? Plus cosine cubed x times the derivative of sine squared. Remember that is the same as sine x quantity squared. So using the chain rule here, the squared is the outermost function. So I would do 2 times the sine x to the first power times the derivative of the inside. Derivative of the inside here is cosine x. Okay. So to simplify this, I'm going to simplify everything on each side of the plus. So in this particular case, this sign can be combined with this sign. So I have a 3 in the front and a negative in front. Negative 3 sine cubed cosine squared. And then over here, I can combine this cosine and this cosine, or these 3 cosines, and put the 2 out front. So it would be 2 cosine cubed x times sine x. And sometimes the book will actually factor out common factors.